production part of data warehousing, and we'll try to connect to what we discussed in the first lecture, right? So let me straight away take you to to the first slide, and I'll start off with some characteristics of OLTP systems. That is, like, they are used for running the operations of the business, and this slide is actually a repetition of the slide we had in the first lecture. But this is important today because of many reasons, because we are going to do a thorough comparison of OLTP systems and OLAP systems, or data warehousing systems, right? OLTP, as I told you, stands for online transaction processing, and OLAP stands for online analytical processing. So typically we have what are called as OLAP tools that work on top of a data warehouse to allow you to do any kind of analysis, right? So I'll just take you back a little bit into the first lecture and talk about these points again, so that we can compare them with OLAP systems in a more detailed manner. So these OLTP systems run the operations of the business. So for example, banks, railway reservations, etc. And they are based on, or they are designed using the ER modeling, that is entity relationship modeling. And it is a transaction based systems. That means they are highly optimized for carrying out the transactions. And these transactions are typically repetitive in nature. And data is always current valued. Like if you see the examples that I've given on top, like banks and railway reservations. So your operational system has to be current all the time. So you cannot afford any kind of latency in updating the data in your operational system. So your account has to be updated all the time. And also when you book a ticket or you cancel a ticket, so when you book a ticket, so it should not be available to anybody else. And when you cancel a ticket, so that seat of berth should be available to the new user, right? So data is always current valued, and we maintain very little history in these systems. That means like a few months history is fine, but we don't store data that is say a couple of years old. It doesn't mean that we don't have that data anymore. It is typically archived and is kept in a separate system. And data is highly volatile because of the number of transactions that are happening, and such systems have intelligent keys. In the last lecture I gave you an example of the ID number of a student, which is an intelligent key. We call it intelligent because it conveys, or it has a lot of embedded information about the entity it is representing. So let me move to the next slide. Data warehouse characteristics, on the other hand, so instead of transaction driven, they are analysis driven, and the queries are ad hoc, so they are not repetitive as in the case of operational systems. So ad hoc queries, and this basically arises from the fact that everybody who is having an access to data warehouse would like to analyze the data in his or her own way, right? So that's what leads to ad hoc queries, and the queries are typically quite complex. And if you are familiar with operational systems and relational databases, so you would know that. So there is a typical operation called as join, right? Join operation, right? And you must also be familiar with aggregate operators in SQL, right? So SQL operators like sum, count, right, average, and there are many more, right? So these are typical aggregate operators. So the queries in a data warehouse environment are typically they require a lot of joins, and they use a lot of aggregate operators, and the footprints of of the queries in a data warehouse environment is very large. That means they require a lot of data to be answered, right? So that is what is makes the queries very complex. And the data warehouse systems, especially when it was this concept was introduced, it was meant only for the top managers, right? So only the top managers had access to the data warehouse. But as we moved forward, right, so the access of the data warehouse was given to almost everybody in the organization, and they were allowed to do any kind of analysis they want to do on the data. And probably they would, the idea behind giving access to everybody is that they might come up with some results, or they would do some analysis, and they might unearth some kind of patterns or information that is not known to us. So that with that idea, the access was given to everybody in the organization, and based on dimensional modeling. So here I'm not advocating Kimball's approach to data warehousing, but most of the implementations of data warehouses follow the Kimball's approach. And in the next module, we'll see why it is so, right? But since most implementations follow the Kimball's approach, and that approach is bottom-up approach, and it uses dimensional modeling, right? So that's why I'm focusing on dimensional modeling, although Inmon's approach talks about a top-down approach, and it uses ER modeling. But as we'll see later in one of the lectures, that none of these approaches are right or wrong. It is about what we want to do and how we want to do, or how we want to implement a data warehousing project. It is more dependent on that rather than the approach that we are taking. And the structures are typically denormalized, so I'll use a different color. Red doesn't look nice. Yeah. So denormalized structures. So if you have designed an OLTP system earlier, so you would have definitely done a lot of normalization of your tables, right? So we typically try to do a 3NF or a Boyce-Codd normal form, right? So that you try to minimize redundancy as much as possible, and by doing so, you are trying to make the updates faster. But here in a data warehousing environment, we are more we want denormalized or flat structures in our system. So, and that is mainly because the data warehousing systems are typically read-only, as we saw in the first lecture, right? So they are typically read-only systems or read-mostly systems. So there are no updates, or hardly any updates. So there is no point in making updates efficient. So that's why we don't go for normalized structures in our data warehousing environment, right? So in the first lecture, I also touched upon the architecture, right? So if you recall that architecture, so what we had was, we had some source systems. From these source systems, we extracted some data. Extraction basically means you select what you want in your data warehouse, right? And then once you select, then you decide what kind of transformations you want to carry out on the data, and then you eventually load it. So there are two aspects of this. One is the initial load. So when you start your data warehousing project and you are ready with everything, right, once you've designed everything, right, so you want to do the ETL process for the first time, and you load the data warehouse for the first time, right? And once you have loaded, so every data warehouse has a refresh cycle. That means every period of time I will bring in new data that needs to be added to the data warehouse, right? So that is called the refresh step. So in many applications, it is a daily refresh. In some applications, it's a weekly refresh or a monthly refresh. So that depends on the kind of organization that you're dealing with. So these are the steps that are listed down here. So let me just clear this first so that you can. Right. So first step is data extraction. So it is typically done using a GUI. So ETL tools typically give you a nice interface to work with. So what it basically tells you is that it shows you the tables that are there in your operational system. So you say that, okay, I select this table, right, first, and then you say that, okay, I want only a couple of attributes from here. So you select those attributes, and that's it. So then you move to the next table, right, and next table and next table and so on. So if you don't want a table, you say that I don't want this table, right, and then you may say that I want this table as it is. So these kind of things typically happen in the extract phase of ETL, and then you clean the data. Cleaning the data basically means that you're trying to fill up the missing values, trying to see if there are any errors or noise points, so you try to rectify them, and you also do a lot of deduplication of data. Say for example, customers, right? So there should not be two records for the same customer, so you try to deduplicate, and let me tell you that this deduplication step is not a trivial step, right? It requires some doing to carry out the deduplication. So I would want you to think in terms of how you would carry out deduplication. Say for example, if I give you a table which has say 1 million customers, right? So try to think about it, and then we'll discuss it when we go to the ETL tools later in the course. And then once you have performed the transformations or cleaning, then you carry out the transformations. So here basically we are trying to arrive at say common codes, right? So for example, male, female, this example I gave you last time also. So same thing can be represented by 0 and 1 respectively. So I have to finally arrive at a common code saying that males will be represented by M and females will be represented by F, right? So something like that. And then there are lots of transformations regarding date formats, currencies, measurements. All those things will come into this, right? And then you load the data into the data warehouse, and finally you do a refresh. So after the initial load, so this, when I say load, that is the initial load, and then you refresh. So this is done periodically, say every day or every 15 days or every 30 days, anything can be there. So let me now move to the next slide, and a few more details about the ETL process. So it is one of the most critical subsystem of a data warehousing system. So it consumes almost like 70 to 80% of project time. So what does this mean? That say if you look at the data warehouse life cycle, and if that is of 100 months, say for example, so 70 to 80 months you will be spending only doing ETL, right? So that is one of the that's one of the major subsystems of a data warehousing system. Then the other issue is that ETL has to interface with many heterogeneous systems. So in the first lecture I told you about that when a company evolves or when an organization evolves, the technology is also changing with time, right? So you use the state-of-the-art technology that is available at that time to build your operational systems. So over the years, what has happened is that some of your systems are using a legacy technology or a legacy system, and then there would be another system which is built using the state-of-the-art technology that is available at that time. So we are basically dealing with a lot of heterogeneity in the source systems, and that poses a challenge to the ETL team or to the ETL tool. And and as a data warehouse implementer, you do not have any kind of control over these source systems. and source systems may be geographically scattered, right? So what this means is that you have to schedule your, say, if you talk about Walmart, so it has operations in many countries of the world. So you have to schedule your refresh or load in such a way that you get all the data before the next business day starts. So that is a challenge. And source systems operating in different time zones, this I just covered. And we are dealing with different currencies. So how do you arrive at a common currency and what currency it should be? So all those are decisions that needs to be taken, and different measurement units. And sometimes you need in your data warehouse some data which is not actually captured by the OLTP systems, because when you design these OLTP systems, the data warehousing requirements were not there at all, and nobody thought that we'll eventually build a data warehouse using these systems. So that's a challenge. So how do you get that data? So for that, we often try to get this data from external sources, say a survey company or something similar. And ensuring data quality is a major issue. So data quality in a data warehousing environment is very critical. It is critical in every environment, but it is more so in a data warehousing environment, because you are trying to deal with so much of data, right? And you are trying to do analysis on that. So if your data is not of good quality, then the analysis would also not be correct. So it becomes very critical to ensure data quality. So that is also the responsibility of the ETL process. And then there's this data staging area. So data staging area where actually the data is processed and prepared to be loaded into the data warehouse. And it's a storage area. It could be just a single machine, or it could be a set of machines that are there. And a storage area where extracted data is cleaned, transformed, and deduplicated. And this is the initial storage for the data. And it need not be based on relational model, although a mix of, so here you have say flat files. You can have data in your flat files. Here you can have data in XML, or here you can have data in RDBMSs. So you can see that RDBMS are the most structured of the three. Then XML is semi-structured, and flat file is least structured. So or unstructured as we call them. So working with flat files is the fastest, right? And this goes down as we move to RDBMS. So in the data staging area, we work only with the mostly with flat files or XML, and not that much with RDBMSs. And it could be spread over a number of machines. And the processing is mainly sequential, and you do a lot of sorting operations in the staging area. And it is common to see a COBOL or C code running against flat files. So that is a very standard way of preparing your data to be loaded onto the data warehouse, and does not provide data access to users. So when the data is in the staging area, nobody has access to it. When I say nobody, I mean the end users who are trying to, or who want to analyze the data. So they do not have any kind of access to this. And a very interesting analogy for this could be the kitchen of a restaurant. So you know that in the kitchen of the restaurant, of any restaurant, you are not allowed in. So there is you can see a no entry board, right, outside the kitchen. So what they do inside the kitchen is they are trying to provide, or they are trying to prepare the dishes that you have ordered, and raw material is brought in, and it is processed, cooked, right, and you are not allowed to see all that. So the customer who is sitting in the restaurant is like the end user, and he has no access to the data while it is there in the kitchen or in the staging area. So that is the analogy which is which explains this particular situation. And then we have the presentation servers. So these presentation servers are nothing but the actual data warehouse, a target physical machine on which warehouse data is organized for direct querying by end users using OLAP tools and report writers and data visualization tools and data mining tools. So the data in the data warehouse can support all these kinds of operations or analysis on the data. And data is stored in dimensional framework. So whenever I use the word dimensional framework, I would typically mean that we are following the Kimball's approach as far as design of data warehouse is concerned. So let me clear this. Okay. And an analogy for this is the sitting area of a restaurant. This is where you are served your dish that you ordered, or you're served with the data that you need for analysis. So that's the kind of analogy you can see. And data cleaning is a very important step in all this. And data warehouse contains, so why we need a cleaning? So data warehouses contain data that is analyzed for business decisions. And more data and multiple sources could mean more errors in the data and harder to trace such errors. And this results in incorrect analysis. That's what I was mentioning a few minutes back. So detecting data anomalies and rectifying them as early as possible has huge payoffs, because all your analysis depends on this. And a long-term solution is that change data business practices and data entry tools. So what you do is that if you know something about data integrity in a relational environment, so if you put if you put a proper set of constraints on your data, so it will be very difficult. It becomes really difficult for errors to creep into the data. Say, for example, if I'm talking about CGPA, right? So if I put a constraint on the CGPA that it can vary from, say, 0 to 10, right? So no value beyond this can be entered. Okay. Similarly, I can enforce a lot of such constraints through key constraints, through foreign keys, and through domain constraints, through check constraints, right? So all those things I can implement. So that's what is being mentioned here. So long-term solution is that you change the way the data is acquired or data gets into your operational systems, and repository for metadata. So you basically try to collect as much as metadata as possible so that you can trace the sources of error if errors are found. And I'll just point you, although this does not come directly this does not fall in the flow of things, but this is an interesting set of algorithms that you would find that are used most often in cleaning the data, and especially for misspelled terms, for example, names. So it works on what are called as phonetic sounds, and so they can be used very effectively for this purpose, for deduplication and other things. So now let me just give you some insights into the design aspect, although it will start from the next module, but I just wanted to tell you a little bit about the design aspects of a data warehouse. So if you now so far what we have seen is that these OLTP systems are data capture systems. So this is very important to understand that why they are called as data capture systems, and I typically call them data in systems because they are the ones which capture the data that is being generated. So say when you make a call, right? So your mobile service provider will record that call, like your number will be recorded, the number to which you're calling is recorded, your location is recorded, your call duration is recorded. So a lot of things are recorded about that call. So what you've done by making a call is you've generated some data, and it is captured in the operational systems. So that's why these systems are called data in systems. That is, they bring the data into the system. And whereas if you look at data warehouses, they are data out systems. So that means that's why these arrows are pointing, these arrows are pointing down here and they're pointing up here. That means I want to take out the data from the data warehouse. Take out does not mean that I'll take it out from data warehouse and put somewhere else. Data out means I want to see what is there in that data. So I want to read that data and analyze that data, what is there in it. So data warehouses are data out systems. Right. So this I'll just go back to the previous slide, and this I've just kept here because this would set the tone for the next lecture that we have. Okay. So where I'll talk about the design aspect. Now, analyzing the data. So there are two basic aspects of this. So one is called as the active analysis. So where user queries, and this is done through user queries, and it is also called as the user guided. I'll just clear the annotations here. So here, active analysis is done using user queries. So user guided data analysis. So what we do is, so it is like show me how X varies with Y. So it could be like how sales varies with time. So once I show that, then you may ask a question like how sales vary with location, right? So you can do a kind of interactive analysis with the using active analysis. And the tool that is typically used is called as an OLAP, which works on top of a data warehouse. Then on the other side, we have what is called as automated analysis. Although this is not the right word to use, automated, right? But that's how it evolved, right? And that is done through data mining. So basically, we ask questions like what's in there in the data. And initially, when people started introducing data mining, they said that it is just like setting your computer free on your data, and it will try to find out what is there in your data. And then we have two kinds of approaches. So one is the supervised approaches, or supervised learning as we call them, and unsupervised learning. Example of supervised learning is classification, and unsupervised learning is clustering. So more on this later, right? So let me now talk about OLAP queries. So let us see how typical OLAP queries look like. So you can see how much of product 1 was sold in 1999 state-wise. So this is a typical OLAP query, and you would you can imagine like how much data would be required for answering this query, right? So because you will in every state, say if you look at a Walmart, and I'm say talking about 50 states in the United States, right? So state-wise, I want for the whole year, right? So you can see how many transactions are happening in each state, right? In 1 year. And then you have 50 states, and in one state you have say 50 to 100 stores. Okay, so you can very well imagine how much data would be required for answering these queries. Next query could be like top 5 selling products in 2002. So how do you do this? How do you find out the top 5 selling products? So if I use the brute force method, what I'll do is I'll find out the total revenue generated by each product, or not revenue, maybe the quantity, say how many units of a particular product I sold. So I find out for all the products that I have, and a store like Walmart may have 1 lakh different products, and so I'll find out the total sales of these 1 lakh products and then order them and then pick up the top 5. That's how I would do it using the brute force method, but that is not how it is done. So if you're familiar with SQL, right, so it provides you with an option which is called as optimize for. So you can actually right, so what it does is it takes it kind of uses the metadata or the data dictionary to figure out which products cannot be there in the top 5. right? So it eliminates those products from the calculations and then works only on the rest of the products. So there's an optimize for option in SQL, so you can look into it to find out how it exactly works. And total sales in Q1 of financial year 2002, 2003, color-wise sales of cars from 2000 to 2003, model-wise sales of cars for the month of January from 2000 to 2003. So one important thing that I want you to note in all these is the time component. So time is often involved in most of the OLAP queries that we run. Okay, so that is important to note. On the other hand, if you look at data mining, so data mining is more trying to explore, or it is more exploratory in nature or predictive in nature. So which type of customers are more likely to spend with us in the coming year? So that's a typical data mining investigation. And what additional products are most likely to be sold to customers who buy sportswear? So you're trying to do what is called as some kind of predictions. So data mining is more about predictions. So that is one aspect of data mining. The other aspect of data mining is descriptive in nature, right? So where you do descriptive analysis. So I'll be talking about that sometime later in the course. And in which area should we open a new store in the next year? And what are the characteristics? So let me just unhide this video for some time so that you can see the whole text. In which area should we open a new store in the next year? So I'm trying to predict something about the future. And what are the characteristics of customers most likely to default on their loans before the year is out? So these are the kinds of analysis that we do in data mining, and it is quite different from what we do in OLAP. And this is an important slide, so I'll keep the video off here so that you can see the complete content of this particular slide. So this is what I call as the continuum of analysis. So you start with the OLTP systems, the systems that you are familiar with, and then you move to what are called as OLAP systems, that is data warehouse, and then you have data mining. So this is the, in terms of complexity, this is where so the complexity goes up, say when you move from OLTP to data mining, right? And here in OLTP what we have is primitive and canned analysis. So some kind of analysis we do at the operational systems also, like if you're running a grocery store, so at the end of the day you would want to find out what is your total sales. So this is a typically canned analysis, right? So you do it every day. Okay, so and the analysis is very primitive in nature. And when you go to data warehouse, the analysis becomes complex and it is very ad hoc. I explained this ad hoc part already. And then in data mining it is automated, but as I told you, automated is not the right word to explain this. Okay, so it is like you need to know what you're trying to do, and then you have some algorithms, data mining algorithms, which would run on the data, against the data, and try to give you what you're looking for. And most of this, when you are dealing with OLTP and OLAP, you are dealing with SQL. So your capabilities of your OLAP tool would be governed by what is possible with SQL, and you will appreciate that nowadays most of the relational database vendors are incorporating new features which are applicable, or features for data warehousing in SQL. So that's a very good thing to see. And when it comes to data mining, so we are writing specialized algorithms for analyzing the data. So this is what is the continuum of analysis, right? So that is the typical sequence we follow. So first we do a course. So if I just relate it to the courses, so first you do a course on databases, and then you do a course on data warehouse, and then you end up you end by doing a course on data mining. So with this, I conclude today's session, and basically I tried to tell you the differences between OLTP and OLAP systems. I gave you some idea about what are OLAP query. I gave you some idea about ETL tools, what they do, what is expected of them, and also talked about the kind of queries that you have in OLAP and the kind of analysis that you do using OLAP, and also compared it with data mining. So in the next class, next lecture, I'm going to talk about just a minute. So in the next lecture, I'm going to talk about the design aspects of a data warehouse. So how you go about designing a data warehouse. So in the first lecture after this, I'll talk about the introduction to. I'll give you an introduction to dimensional modeling, and then follow it up with a very simple case study, and the case study will be the grocery stores case study. So with this, I end today's session.